Hello and welcome to the presentation of using e-learning standards to improve serious game deployment and evaluation. In this presentation, we're going to learn the most frequent teacher issues and problematics when using serious games and how can we use the educational standards to solve them. Thank you for coming in and let's begin. Serious games have proven to be effective learning tools for purposes like teaching, creating awareness, changing behaviors, obtaining skills, and more. However, when a teacher approaches them to use them in a real environment, he faces three problems. First, it is not easy to know their real effectiveness. They work as motivational tools, but there are not enough metrics to evaluate the students and to use that in a real curriculum. Second, to give the games to the students, the teacher highly depends on how well the game integrates with his systems. With a bad integration, the teacher work grows exponentially. Finally, the teacher needs to know what their students are doing and how are they playing in order to detect edge cases and assist them properly. One of the most popular trends is game learning analytics. This special type of analytics sit in between the pure game analytics and learning analytics to massively trace the student interactions. These interactions are then data-mined or visualized to extract metrics and help the teacher understand if their students are on the right track. But game learning analytics is not only good to measure the effectiveness. Since these analytics come in real time, they can be used to monitor the students. However, in the end, to use game learning analytics, it will require more infrastructure and thus increases the cost of the activity and its configurations, worsening our deployment issues. We believe that, by using educational standards, we can solve these issues. When a teacher wants to use their LMS to simplify his issues with serious games, he will go through a three-step process. First is finding the game. The most easy is searching in engines or repositories, but it might be possible for him to use existing tools to adapt or even create his own games. Then, he has to solve the problem of giving the students the game. In the best case, a tool will assist him, but he may choose web-based games since they are more easy to access than native games. And finally, he has to think on how to integrate the games. If the game provides some results, he either will have to collect them or find a game compatible with an educational standard, such as SCORM, that will help him to do the job. But when it comes to use the games as effective learning tools and include game learning analytics, the things get more complicated. The Learning Object Standard was created to solve these issues. With the pass of the time, this concept has evolved to an ecosystem of standards for three main purposes that fit with the previous teacher problems: discovering or cataloging the games, providing control access to the activities, and communicating the contents or activities. Besides of their functionalities, most standards share points in common that fit in one of our following categories: providing a metadata system to catalog contents, providing a packaging system to easily distribute or connect the contents, provides a way to deliver students to the activity, generates a simple result in completion score pairs associated with students, provides a more advanced report protocol, and finally provides a data model to format the data. Let's dip into the standards to know more about them and how we can use them. First of all, to discover serious games, we have Emslom, which adds a tagging system to facilitate indexing content. This standard was used inside both main learning object standards, such as EMSCP and SCORM. Then, to access the activities, we have three alternatives. EMS Content Package provides a simple packaging system to self-host and reuse the contents within the A structure. It is very simple to use, but only works for web-based contents, like WebGL HTML5 games, since Java and Flash are mainly deprecated. EMS Common Cartridge evolves from Content Package and adds more flexibility to its packaging system that makes it similar to SCORM. It allows accessing external contents and result reporting by using LTI links. Finally, EMS LTI, or Learning Tools Interoperability, however, is another complete different story. It communicates the learning management systems and the tools, forwarding the student's authentication and authorization to the tool and lets the tool manage the activity. Then, it allows the tool to return completion and scores. LTI is simple for the user but only works in web-based scenarios. To communicate results and evidences, we have two different approaches. First, in the left, we have the Learning Analytics Standards for formatting. XAPI is the most popular one, adding just a data model and an API. This data model is used to trace the interaction, identifying the actor, the action done, the target, and a context. Also, it includes domain profiles for specific cases such as serious games. Caliper is the EMS alternative, but has less adoption and support. However, as we mentioned in the beginning, both XAPI and Caliper require extra configuration and infrastructure to be applied. On the right, we have two packaging protocols that also support communication. SCORM is the all-in-one for learning objects, including reports and adaptive system to content packages. However, due to its limitations, such as being web-only and the very limited reports, ADL created CMA5, which solves all of the SCORM issues, providing an all-in-one solution for activities with learning analytics instead. In addition, it allows for native support. However, although CMA5 may be the solution for all, it still suffers from very limited adoption. Here we can see a very simplified scheme of the evolution of the standards, their hierarchical distribution, and functionalities. As we can see, SCORM includes both LOM and CP for packaging, but also can report results. EMS Common Cartridge does something similar, but includes LTI. And finally, CMI5 provides all the functionalities, including learning analytics. So now, how can we use these standards effectively in serious games, especially if we want to support learning analytics to solve the teacher's confidence and control issues? Considering the current adoption of standards, we describe two approaches for two use cases: web hosting the serious game in the LMS, or integrating native serious games in the LMS. Hosting the games in the LMS is the most simple and compatible approach, and can easily integrate simple grading and evaluation. The type of content is limited to web-based, but there are multiple engines to create these contents, including multi-purpose engines like Unity and Unreal Engine. The exported WebGL content is then shipped in EMSCP, CC, or SCORM and will run inside the LMS. Despite SCORM and CC can be used to transfer simple results, we highly recommend including a learning analytics tracker in the game. Then, provide individual identifiers or pins to the students to gather learning analytics data into a learning record store for later analysis. The second approach includes all the previous functionalities, but it has learning analytics support straight ahead. The idea is to solve the CMI5 lack of support in the main LMS by connecting it to another tool that has a CMI5 support through LTI. Then this mediator tool will be the one to launch the game and store the XAPI traces. The public SCORM Cloud platform allows doing this, but also we have a similar approach in Simba that will be explored next. This approach will allow using any kind of content, but it is especially interesting the case of native games in smartphones. The grades will be forwarded to the LMS through LTI, and the effectiveness and monitoring is accessible inside of the mediator tool. We have implemented both approaches as a proof of concept using our open source tools. eAdventure is an authoring tool that will help with the development, creation of the packages, and the generation of XAPI traces. It is an authoring tool for narrative and geolocated game styles, easy to use by non-experts, and includes support to game learning analytics out of the box. Also, it is capable to export both native and WebGL contents. Simba is a management tool and will act as the mediator, connecting with LTI and doing the CMA5-like launching. This tool is a multi-purpose validation tool capable of managing experiments data, users, and do data science with the results, even in real time. Also, it is GDPR compliant with this PIN system and integrates well with e-Adventure. In our first approach, e-Adventure automatically exports the EMSCP package storing WebGL contents. This package is then uploaded to an LMS, and by using the individual PIN, the student is able to play and generate traces. The second is a little more complex. The game can be exported in both WebGL and native formats, but a CMA5-like package is generated instead. This package is hosted in Simba and accessed through LTI links. For students to access the content, the teacher adds the LTI link in the LMS, and when the student clicks it, the game is launched seamlessly. In this approach, the student is automatically identified and the results are propagated to Simba and the LMS. In conclusion, to make game-based learning possible, games must be easier to deploy in the class and to integrate in the curriculum. The e-learning standards provide a lot of solutions to the problems and can help to systematize the process, even providing support for game learning analytics. To use them, we have shown two different approaches: that of using EMSCP packages to store WebGL contents using pins to associate traces to students, and that of using a mediator tool to bring CMA5 packages to real LMS by using other standards such as LTI. Both approaches have been tested as a proof of concept with e-Adventure and Simba. And this concludes our presentation. Feel free to contact us to learn more about our open source tools. Thank you for your attention.